Hi, so thanks for joining today. We're going to take a tour of GROB Systems in Bluffton, Ohio. For those of you who don't know much about GROB, we're a family-owned company, started over 90 years ago in Mindelheim, Germany. The Bluffton facility started in the 80s, and the machine tool side really began around 1990. And the location for Bluffton was really selected based on the location next to the airport right here, and also we're close to a lot of our customers in the Midwest. When we started in 1990, we really started as a small company, and we've grown since then. We're now over 550 employees. And we have four main product lines. We have system machines, universal machines, assembly equipment, and equipment for e-mobility production. So today we're going to head back to the production facility and we'll take a tour. So the building's behind me here. This is kind of where it all starts. The building at the end is our proposals and sales office. Then in the middle we have our mechanical engineering, which does all the customizations for the equipment. And then next we have our electrical engineering, which makes it all come together with the automation and all the customization. So here we'll enter the main factory. So the first area we're going to enter today is the apprenticeship area. It's very important to our company. It's been in place since the beginning in 1990. It was a very small group, around 4 apprentices, and has grown every year since then. We actually had our biggest year 2 years ago with over 40 apprentices in that 1 year. And it's a 4-year program which really combines hands-on training with classroom training. And recently it had also been split between mechanical trades and electrical trades. So from the mechanical side, they really start from the basics. And actually behind me is a good example. We had a class start a couple weeks ago. And really the first tools they get a file and then they get a hacksaw. And now they have projects which really teach them the basics, how to use those tools. For this example, they have 2 pieces of metal and they have to make a dovetail out of it. They hold it up to the light. If you can see light through the dovetail, it's time to start over and try the next piece. So it really does teach them how to use that from the beginning. And then they progress through that whole range of tools and machines. So they graduate to a drill press, they go to a manual mill, a manual lathe, and they end up at the end on a 4-axis CNC and a 5-axis CNC. So they really take that whole path to learn the basics. And in that time, they also spend time in every department in the company. For example, fabrication, subassembly, final assembly. And they do that so they really understand why in the end, when they get placed in their final position, why they do what they do. So they don't become experts at everything, but they understand the reasons behind it. Now on the electrical side, they start with building wires, building wiring panels, and they go through programming PLCs, programming robots, and also then in the end programming CNC machines. So they take a similar path on the electrical side too. And at the end, after the 4 years, they're placed into the final position in final assembly or even engineering. It depends on the candidate, but they get placed where they're best suited within the company and where our needs are. So here you can see here, they'll have projects in this area, they'll have projects over here, and they rotate throughout the years to learn everything within the program. So lathes, basic projects here, drill presses, manual mills, and at the end here you'll see a 4-axis CNC and a 5-axis. And actually our electrical lab is upstairs. There's robots up there, PLCs that they do projects on, but here you can see the 4-axis, and right behind you here it would be the 5-axis, one of our universal machines. So with that we kind of exit the apprenticeship area. Now we go into our production area, where we build our own components, our own machines where we can. So if we come here, first off we have a 4-axis 800 millimeter machine. This is a little bit of an older version. It's not really marketed today, but we have similar products, but it's still in production for our own use. And you'll see several as we go through the area where we use our own equipment. So 4-axis here. We also have several grinders over here. We don't make grinders, so these are from other suppliers, but some flat grinders, some round grinders, also over there. Also at the end here, we have our CMM lab, if you want to come here and have a look. So in the CMM lab, we do 100% inspection on our own parts. Also on customer parts, we do runoffs. We'll do the inspection here to prove out the process 100% before it leaves. Over here, we also have we use our own 5-axis universal machines. We have some 550s, some 350s that we use for our normal production. Over here we have a 5-axis G550 with a PSSR. Also has an external tool magazine, so very flexible, can run lights out in the evening time. Next to it here we have our largest 4-axis machine. It's what we call our BZ1600. It's a 1600 millimeter pallet horizontal machine. And we'll keep heading through the production area. So to the right here, we also have some jig bores. So we'll use these for the fine finishing work on certain components, fixtures, whatnot. And you see 2 of them here, actually 3 of them now. And also in this area, we have our own CNC programming is here, our own tool crib is in this area. And we do everything in-house. We're not outsourcing anything. We keep it all in-house. We're very vertically integrated. So next we're gonna head over here. We're gonna look at one of our larger machines that was specially developed for certain part types. So this machine behind me is what we call our GP2050. We specially designed it for some of our own part types. We really couldn't find a machine on the market which was what we needed, so it was really developed to machine certain part types like Y-axis slides. Over here we have some A-axis trunnions. We also do Z-axis slides, AB-axis. So a lot of those larger part families really work well on it. It is a 5-axis portal machine with a 2-meter pallet. And here at the end we have one machine connected with a robot system and 2 setup stations. And actually at our headquarters we have a line of 4 of these all connected to one load system. So it really filled the need that we had within the company to make these parts on our own. So next we'll head over to the machine back here where we're making our bases. So back here we have our large bridge mill we use for all machining of our bases. We added this about 10 years ago. Prior to that, we had been outsourcing all the base production. We brought that all in-house just to keep everything within our control as much as possible. And what's unique about this is we had actually bought this machine off of one of our customers, and we had completely retooled it and put new software and controls on it all in-house. We didn't rely on a third party to do that for us. So it gives you an idea of the expertise we have in-house to do integration. So it is one of a kind, probably one in the world, Ingersoll machine with a 840D control on it. Over here, we have a large machine for doing gantry production, so long beams, long conveyor rails are produced here. Out here in the breezeway, we have our powder coat area, so we do all our own painting, and all prepping of raw material is done out in this area. So that was an investment we made a couple years ago as well. We were doing mostly wet paint, now we're doing everything with powder coat. Okay, so now we're going to enter the fabrication area. So in the fabrication department, we're making all our own small weldments, enclosures, safety fencing, all in-house. Over here on this side, we have all weld booths for all the manual welds that need done. Over here, we have some lasers, some press brakes, and also a shear behind you. So everything on the machine enclosure is done here at GROB. So we just passed one laser. Here's the second one. This one's automated, runs around the clock, unattended. And past here we have our press brake. So now we've kind of left the production area of the factory, and we're getting into this middle section here, which is more subassembly. So we have more electrical assembly, fluid assembly, and then mechanical subassembly. So behind me here, starting with the electrical, we have rolls of cable, so we can cut cable to length, we can terminate the ends, do it all in-house. We're not relying on a sub-supplier to make cables for us. Then once the cables are made, everything gets kitted up on the carts per machine or job, whatever it may be. That way when it goes out to final assembly, you're able to have everything you need right there with you. Next up will be our panel shop. So here in the panel shop behind me, Everything is built on the back plane ahead of time, wired, and also labeled. Once it's all put together, it'll be mounted on the back plane of the electrical cabinet, and now it's ready to get set on the machine in final assembly. So now we're getting into the fluid subassembly area. Here we're putting together all the manifolds, assembling it to the pumps, putting it in the enclosure, put the accumulators on, as much hoses and pipes as possible. So we do everything in small components. That way when we get out to final assembly, it all happens much quicker. Next is mechanical subassembly. So the area behind me now is mechanical subassembly. Here we're putting together all the custom fixtures, the cross slides, the Z-axis, the Y slides, AB tables. Every small component which goes on the machine will get subassembled here. Some of the components have to go back to the CMM lab to get inspected and also to get fit spacers made. That way when it goes out to final assembly and mounted to the machine, it's good to go. So everything starts here. Fixtures get tested on test stands ahead of time to really make sure that the final assembly process goes quick. So next here we'll go to the area where kind of the different sub-assemblies come together. For example, right here now is a cross-slide and Z-axis for a G350. So it's a mechanical assembly. Now we're going to mount, all of the cables are mounted by the electrical technicians. All the pipes and hoses will get connected. And also when we look at our cross-slide, this really is one of the big benefits of a GROB machine. Our cross-slide has 3 sets of bearings on the Z-axis, and the bearings actually travel with the Z-axis. So it doesn't matter how far your Z-axis is retracted or how far it's out in the work area, you have the same rigidity. If you look at any other vertical which is out in the market, the closer you come down to the part, the less rigid it is. So the GROB machine really is the most rigid when it's out at the part. Glass scales are standard on all axes as well. And also here we have a hood. So the hood will actually open for tool change, which is really a key benefit as well because our tool change happens completely out of the work area. Any other machine tool out on the market, the longer your tools get, the smaller your parts have to get. So you're going to, in that case, you need a larger machine to machine what may fit in a smaller GROB machine. So this is the key to our machine here. It really provides some big benefits. Also here we have our AB axis. This is out of a G550. Again, rotary scales are standard. Torque motors on the A axis and B axis. If you come and look at the table itself, the bearing size compared to this distance here is almost a 1-to-1 ratio. So you have a good lever and a lot of rigidity involved. And also, if you look inside a machine, you only see this sticking out. If we come and look what's behind the work area, now you really start to see where the torque motor, the brake assembly, the fluid connections are, and you really start to see how it's a balanced system. It's also lifted on the Y-axis by two bearings, which is unique as well. Most competitors only have one vertical ball screw. We have 2. So we'll head over here towards the magazine assembly. So now we're heading into the magazine assembly area. So we have a couple different types of magazines, depending on the type of machine, double spindle or single spindle, HSK 63, HSK 100. So we have to configure it differently. But as an example, here we have a HSK 63 double disc, and we have a tool loader here, which will bring the tool from the magazine. It then gets brushed and cleaned before it then goes down to the spindle. So that's also unique for GROB. We're always cleaning the tool before it goes to the spindle. That really makes a big difference on reliability. So that's some other examples. For a HSK 100 on a G550 access machine, the tools are held horizontal. It's a different type, but the spindle will go directly into the magazine and pick the tool out directly. A couple more examples, HSK 63 with direct pickup. And here we also have a HSK 100 double disc. So this is another configuration where we have a load arm, which takes the tool out of the inner disc, places it on the outer disc, and now the spindle can come and get it here. All versions, as I mentioned, the tool brush happens prior to going to the spindle. So this office right here is our service and final assembly administration. So what's key here is you have the support in Bluffton, and we're all dedicated towards machine type. So when you have problems with an assembly equipment or a universal equipment or system equipment, you talk to the right person who knows that equipment. Remote access to most machines, you allow us to have access, and they can do it all from Bluffton here. The next piece of service is spare parts as well. So down here we have a new spindle rebuild area. So for the most part, we're using GROB-made spindles in our machines, and those types we're rebuilding in Bluffton. So we started doing that several years ago, and we had a much smaller area. The key to that is we want to keep everything in-house. We don't have to send spindles back to Germany. We have the expertise here. So we expanded the area. We're about 5 times bigger than we used to be, and this opened a couple months ago. But here we have several test stands which we built. All the spindles get ran off on the final checks in this area before it would ever go to a customer. In this half of the rebuild area here, we're doing the disassembly and repair and replacement of parts before it goes to the test stands. And over here you can see all the spare parts we have available for service, and also the spare spindles. So we have several racks here with many different spindle types which are ready for use. All different types that we offer are kept in stock, and we're not relying on our headquarters for spare parts. So this area here, we have more subassembly. This is mainly of conveyor, gantry sections, assembly equipment. So less precise parts are assembled in this area before they go out to final assembly. So this area here is our application center for our universal machines. This office, we have application engineers who can do test cuts, turnkeys, time studies, customer support would come out of this area. We can also do trainings here or at the customer, whatever is required. And past this, we have several machines which we're able to use for all those activities. So in this area, we have kind of a showroom where we have some display parts. So many different markets: mechanical engineering, mold and die, tire molds, automotive, aerospace, power generation. So many different applications we have experience with in Bluffton. And also we have a lot of videos online. If you visit our YouTube channel, you can see a lot of these parts being made for those many different markets. And as I mentioned when we started, we also have an e-mobility product line. And the purpose of that is in the past, when it came to battery assembly, rotor stator assembly, it was all done more of a manual fashion, but now the automotive market's going pretty heavily towards some type of electrification. So we've developed a product line that makes it possible to mass produce battery packs, rotor stator assembly. So these are just some examples which we can offer for that solution. Okay, so we'll head into our application center now. You see there's several different types of machines here. Our 350, 550, and 750 are all available for testing. Here you can see our G350. All machines are built on the same platform: horizontal spindle, AB axis on a Y-axis slide. We also have our 550T, so 630 millimeter pallet, but it's a mill turn machine. So main difference: different spindle, different table. Now we can spin the part on this size up to 800 RPM, and we can do turning applications on a milling machine. Over here we have our PSSR. So it's a pallet system for up to 13 pallets, and this goes on our 550 size. We also have a version available on our 350. And this is a complete GROB product, down to the software itself. So the software can be operated in a manual mode, just drag and drop like an application on your phone, or you can set up jobs like a production order. So it can be ran in both scenarios. So it really is a flexible solution for a lot of customers. And it's connected, as I said, to our G550T. And what's really nice here is the access to the work area. So we still have a good view. We can open this door here, then open the operator door, and we can still go in to check parts, check tools, So access to the work area is really the best you'll find out there. So now we'll head out for Application Center. In here we actually have our G750, our largest universal machine at the moment. So same basic design, 800 millimeter pallet, 230 degrees travel on the A-axis. So the A-axis travel is another key benefit that we have. It's much greater than what the competition will have. And as you can see, the table can go upside down, which is perfect for machining upside down, having chips fall down, or at least dumping it off before the part is done, which is key if you have any type of automation to keep the pallet clean, the part clean, that you're not dragging all those chips and cooling out with the part itself. So all these different machine types are available here in Bluffton for test cuts. And now one more product line we have is our G550 with a linear system, which was new last year, and we're actually building one here. So a 550 with a pallet changer on it, but it's also connected to a linear system. So storage racks inside. It's not finished at the moment, but pallets will be stored on the 2 racks. Can be expanded to up to 5 machines. So that's a big difference from the rotary system, which I showed just a minute ago. It can only be for 1 machine. The linear system can connect up to 5 machines. This is a universal product. You can see at this point here, now we've assembled the base, all the main subcomponents, all the wires are done, the hoses. The main thing left is the enclosure. So at this point, all the geometry checks are done. That way, if any adjustments are needed, it's much easier to do it with the sheet metal and the enclosure removed. So at this point, we started up, geometry is good, finish the enclosure, then we do the final startup and checks on the machine before we do either send it to the customer or do a runoff. So here we have an example of a systems type solution. When I say systems, that means it's mainly for automotive solutions, powertrain components mainly. And it's typically when you need 100,000 pieces a year or more. So customers come to us, they say, I need this X number of parts, these are the operations, and we come back with a proposal to do it from start to end. So everything you see here in this line was engineered and produced in Bluffton. So just to give you a couple examples of what's in the line. So first we have what we call a special purpose machine, and this can be many different things, from heavy duty machining like crank bore, measuring systems, and that's what this is. Part comes in, measuring system comes down, we're gauging some hole sizes, measuring system goes out, gantry then takes it, and now we go to a machining center. Inbound and outbound conveyors for the parts are here, and we have several double spindle machines. So for example, I said we do everything. So it's the machine, it's the fixture, it's the process, start to end, all done in Bluffton, all supported in the end by GROB. When we go further down the line, we have more operations with different types of machines again. So at the end here, we have 2 single spindle machines, which are doing the combustion phase of a cylinder head. So we're combining all these different types of technologies and engineering into one system, which is highly productive. I mean, something like this will produce tens, thousands, hundreds of thousands of pieces per year. So it really depends on the process, but that's really where GROB got its name in the machine tool business, is this type of solution. We also do machine reconditioning. So these 2 machines here were actually in production for, I think, close to 15 years. Now they came back, the customer wants to produce a new part type. We go through it, look at bearings, rails, control system, evaluate what needs to be replaced. Then we put a new fixture, a new process, we run it off again, and this will go back into production another 10 to 15 years, depending on what the customer needs. So we do that part of the business as well. So you can actually see a machine that's headed out to a customer, it's been ran off. The process was completely bought off by the customer. Now we'll go back, set it up, redo the runoff. So here you can see a series of production of universal machines. Down here at the end, you can basically see a base with rails on it, and now it's step by step. Now you have a table. Here now you have a spindle, coolant system. So step by step, everything is assembled before the electrical parts and the fluid parts are assembled. So step by step, and this process really happens pretty quick based on how in the subassembly area we go everything component by component. Makes it really fast out here. So before I talked about another business unit we have, which is assembly equipment, and that really complements our system solution. So if you machine a head or a block, typically you have to put cut plugs, threaded plugs, bearing caps. It needs to be leak tested, and we can do all that as well. So this is a very engineering heavy type of equipment where everything's custom, and we'll do that from start to finish in Bluffton itself. So down here we have an example we can show you. And there's a couple different levels of automation which can be done. It can be as simple as the parts on a pallet, it goes from station to station, and then you have an operator which comes and, for example, puts the head on the block and puts the wiring pack on and so on. That would be a pretty manual solution. Then we have solutions where you have the parts palletized, it comes in, let's say the operator puts the bolts into the head itself, and then a robot comes in and tightens the bolts. That's kind of a semi-automatic solution. Then we do full automatic where the part comes in, all the bolts are fed, the robots are tightening all the bolts. So really there's no operator intervention except loading parts. And here we have an example over here of one of those. So parts aren't running in the cell right now, but it's running a dry cycle to prove the logic, prove the equipment is functioning. So this is putting in cut plugs with Loctite, pressing them in, threaded plugs, torquing them, recording all the results. So it's closing up the block or the head, whatever it might be, all in a fully automatic solution. The only thing that is required from an operator is to load parts and cut plugs, for example, or bolts. So the robot is picking up out of the incoming conveyor, bringing it to the Loctite station, then pressing in the cut plugs, going to another station, threading in the threaded plugs. Once it's done, it'll come on this conveyor here. We'll come to the next cell. So the part comes into this cell, robot picks it up, puts it in the leak test. Leak test closes up, air pressure is put into each channel in the engine. The leak rate's tested, and we can prove that the casting and the machining is where it should be. So in the end, you have a product which is not leaking on the floor or having damage in other ways. So again, from start to end, this is just one example. We have a lot of examples of assembly equipment. It really depends on what the customer needs. So when we have a turnkey on a machine, we're supplying the fixtures and the tooling. So the tooling, we are working with the suppliers who actually make them to design them to our process. So once they're all purchased, they come here, everything's checked. Before it ever goes out to the machine, the runoff will happen. All the tools are coming back to the crib here, they're checked again, and then they're sent out with the machines. So you can see there's quite a massive amount of very expensive tooling here, which is just a big part of what we do. Over here we have a couple more universal machines. These are G750. These are mill turn machines. So 500 RPM on the table with an 800 millimeter pallet. You can see the double disc magazine, HSK 100. Again, dual drives on your y-axis. And again, as I pointed out before, this bearing size from here to here is 1-to-1 ratio basically. So you have a really rigid system with good access yet. So we also have some CMMs out in our assembly area. And the main purpose of this is we're able to, when we do a runoff for a customer, sometimes they send the CMM to us to prove out that as well. So that way when we have final runoff at a customer, the results are matching what it was here. So it really does make that process go much quicker, and we're doing that in support of our customers. So today I showed you really a brief portion of what we do here. It really is quite an impressive facility, around 400,000 square foot. We invite customers to come visit us anytime. It really is quite impressive. So thanks for your time and listening, and hope to see you.